In this lesson, we'll discuss how to solve compound interest applications. The question reads, how long will it take in years and months for an investment to double if it earns 7.5% compounded monthly? So this is periodic compound interest, where we are told that it is being compounded monthly as opposed to continuously. The compound interest formula is shown right here, and the variables are described underneath. They're asking us how long it will take, so they are looking for T for an investment to double if it earns 7.5%. 7.5% represents R, which is the interest rate per year. So let me write that down. R is equal to 7.5%. And when you're dealing with interest, you want to convert it to a decimal. So to convert 7.5 into a decimal, we divide by 100%, and we end up with an R value that is 0.075. It is being compounded monthly, and this will give us insight as to what to set n as, which is the number of compounding periods. Compounded monthly means n is equal to 12 because there are 12 months in a year. T is what we're looking for, so I'll just put a question mark. And the principal, which we assign as the letter P, is related to our amount. We're not told what the principal is or the amount, but what we want is for the principal to double. So I'll set A as 2 times the principal, and the principal will be just left as P. With that being said, I'll substitute all these values into this formula. I'll first replace this A with 2P, 2 times the principal. P bracket 1 plus R being 0.075 over N, which is the number of compounding periods per year. We found out that is 12. Raised to the power of N times T, so 12T. We need to solve for T. The first thing that I'll do is divide both sides by P. And what this will do is cancel out the P's on both sides, leaving us with 2 is equal to bracket 1 plus the following fraction raised to the power of 12t. Remember, we need to isolate for t, and it's in the exponent position. So to get it down in a location where we can isolate it, we have to ln both sides, because lnning both sides will take the exponent, according to the logarithm laws, we'll take the exponent and make it a product of the expression. So I have ln 2 is equal to 12t times ln 1 plus 0.075 over 12. Now that I have t as a product of this expression, I'll divide both sides by 12 times ln 1 plus 0.075 over 12. And if I divide this side and that side by the same expression, what happens is all of this will cancel out with those factors, leaving us with only t on the right side. Okay, let's go ahead and find out what the left side of the expression equals to. Ln 2 divided by, in brackets, 12 times ln 1 plus, in brackets, 0.075 divided by 12, close, close. And we get 9.27 years. 9.27 years. They want the answer in years and months. And we can't report 9.27 years. So I'll take 0.27 years and convert it into months. So there are 12 months in a year. I'll write down 12 months per 1 year. This cancels out, and we'll multiply 12 times 0.27, which is 3.24 months. So I'll say it will take 9 years and 4 months. There you have it. That is how to solve compound interest applications related to time.